Hi, welcome back to the series on performance tuning SQL Server. In this video, we're going to explore how design impacts performance, and more importantly, the kind of decisions that we end up taking without really realizing whether it's a good thing or a bad thing. For example, in this particular video, I'm going to show how I evaluated between three different options and then had to decide on which would be the best option available. And the example here is basically this particular table. So let me just go ahead and show it to you real quick. This is something that came up as a result of a discussion that we were having internally about how to store some data. And what we have here is we've got a table called attributes, and in this particular case what we're seeing is we've got a listing, and against the listing we have a number of different attributes related to a flat. For example, it could have parking, it could have bathrooms, bedrooms, a dryer, AC, etc. So we have a number of things that we want to capture. And at the end of the day, what we really want to do is have users be able to query this data and filter listings based on the filter criteria that they're looking for. The first option is obviously this particular scenario where we just have a primary key column, which is a listing ID, followed by one column for every attribute that we want to capture, and then the appropriate values stored as you can see here. The next option that we considered we could do was basically store this data as key value pairs. So I'll just show you that example here. Just a second. And here what we have is basically just a listing broken down, pivoted into its key value pairs. So I could say something like listing ID equal to 5, and that would show me the same columns that we had earlier pivoted so that we see it in this format. The last option is also something that I see quite frequently being used, and that is to go ahead and store the data in XML format so that it would look something like this. And as you can see, in all three cases we don't really lose any information. The amount of data that we capture is still the same as before, and all we're really doing is essentially just trying to represent the data in a different format, and then trying to understand whether each of these formats give us any conceivable benefit over other formats. In this particular scenario, the obvious advantages that we get with listing XML as well as key value pairs is the flexibility of the design, where as more attributes are being added, both of these designs will obviously be able to scale, not scale exactly, but incorporate or adapt to the design changes. And that's exactly the same thing with JSON as well. We didn't consider JSON in this particular example only because it's not a native data type, and as a result indexing is not something that we can rely on, and performance is obviously one of the considerations that we had to use when we came up with this design. So in this first scenario here, what we've done is we've created a table, a flat table, and as you can see we've got a clustered index as well as a column store index that allows us to go ahead and achieve massive amounts of compression simply because of the fact that a lot of the data is duplicated. The next one that we have here is the key value pair, where again we have a clustered index on the listing ID over here, and then for the combination of key and value we have a non-clustered index. And the last one is obviously the XML, in which case we have an XML data type, as you can see here, followed by the standard indexes that you apply to XML columns. So let's go ahead and measure the performance impact of each of these design approaches. In this particular scenario, this particular query, you can see we have a start date and a start time and an end time, which we will be using to calculate the time in milliseconds it takes to finish the query, the number of rows returned as a result of this query, and the number of rows returned per millisecond, which is basically just row count divided by time in milliseconds. And to start off with, I'm just going to say between 1000 and 2000, and we're going to execute this, and you'll see that for somewhere between 1000 rows we're getting approximately a speed of 31 to 32 rows per second once the data is cached. Obviously you can see 74, that's not too bad. Oops, sorry, let me just go ahead and apply this to all the other queries as well, and then we can explore them in much more detail. So in this particular case, we're querying the XML table, as you can see here. So for 1,000 rows, we're going to query the XML data, and you can see the filter criteria over here saying that we're searching for all flats where the gym is 1 as well as a sauna is 1. And I'm going to go ahead and execute that, and you'll see that for about 1,000 rows, you're getting roughly about 2 rows per millisecond, which is not really all that great. And what we'll do is, similarly for 1,000 rows, we're going to go ahead and look at the key value pair table. And as you can see with the key value pair, while the scalability increases, the complexity of querying the data increases proportionally depending on the number of columns that we might need to filter on. And this is obviously one of the big challenges with key value pairs, and something that keeps coming up on forums. So for 1,000 rows, you can see that the key value pair again returns roughly about 15 to 17 rows per millisecond. So it's at this point the key value pair definitely seems to be better than the XML, which roughly corresponds to about 2 rows per millisecond, whereas the key value pair translates to about 17 rows per millisecond. Next, we have the standard table with the column store index on top of it. And for the column store index, you can see that we've really got a very good performance in terms of 37 rows per millisecond, and occasionally more than that, but on average about 30 rows per millisecond. So to start off with, we can see that for a small number of rows, when we're querying a small number of data, the key value pair is in second, the XML is in third place, and the column store index with a flat table is in first place with the maximum number of rows returned in the least amount of time. And as you can see here, the row count for all of them is 222. But let's see if this scales to a larger data set. So I'm going to say between 1,000 to 200,000. Now in this case, we are querying a much larger volume of data. So as a result, we should be able to see whether the solution scales up when a large amount of data is being queried and we're searching millions of listings. A similar example would be something like products in Amazon, rather than maybe flat listings, which usually might not go into 200,000. So to begin with, we have the XML, and immediately itself it becomes clear that the XML isn't scaling as good as we would want it to. You can see that it's close to about 11 seconds now, and it's about 4 rows per millisecond. So as the volume of data increases, XML obviously doesn't scale well. The next option we have is a key value pair, and this key value pair obviously a little bit faster, and as far as we can see, not really much of an improvement in terms of the number of rows being returned per millisecond. So you can see that it kind of hits its limit at 19 rows per millisecond, regardless of the volume of data. And that's what we're seeing here. So as you can see, the XML obviously definitely gets worse as we query larger volumes of data in terms of the execution time. And also, as far as the key value pair is concerned, we see that we don't really see any improvement regardless of whether the volume of data is large or small. And for the column store index, what we will see is, yeah, we've got slightly better performance. Earlier it was averaging roughly around 31 rows per millisecond, and now we are somewhere close to about 52. So as the volume of data increases, it seems that in terms of being able to scale up to meet the requirements of the throughput requirements of being able to scan large volumes of data, the column store index definitely performs better than a properly indexed key value pair or an XML. And that's kind of the point that I wanted to make with this video, in terms of being able to design a database, not just keeping the current requirement in mind, but at the same time seeing how it would scale in future. So designing a table so that it will last for 3 to 4 years requires being able to understand the options and evaluate the pros and cons of each of one of them. And I hope this video makes that clear. There is obviously other things you can do, but I think for this demonstration there will be a good place to stop. I hope you enjoyed this video, and thank you for watching.